Hello, everybody. This is Nick Terrell, Professor of Information Technologies and Computer Science, Lakeland College. In a previous video, we talked about error and exception handling, and we covered the first two basic errors, syntax errors, which are grammatical errors, spelling errors, things like that, in which the interpreter or the compiler, if it's a compiler-based language, would find them immediately and spit them out and say, hey, line 21 has an error in it, you need to go fix it. And we talked about logic errors, and those are the ones where the program is running, but you're not getting the results that you want. And be honest with you, those ones will drive you absolutely crazy. You can spend a long, long time trying to fix your logic errors. And I kept mentioning something called a runtime error. Now, a runtime error means that your syntax is fine, your logic is fine, but something may happen. And typically that something could cause a catastrophic error where the program literally just stops working and bounces you out to the operating system. And in just a sidebar, in the world of security, anytime a program stops working and bounces you out to the operating system, that's a really bad thing, but that has to deal with secure programming techniques. So a runtime error means that your syntax is fine, obviously it's running. Your logic could be fine, but then something happens. Let's say, for example, you're writing a program that's reading a file. Now, we're not going to do that in this demonstration. You're writing a program that's reading a file, and you mistype the file's name. Well, the syntax is fine, the logic is fine, but when the program executes and goes looking for that file, it's going to say, can't find it, and it's going to kick out an exception. The more common one that we use for teaching that you will often see in a demonstration is dividing by zero. You cannot divide by zero. So let's say you're running a program and that particular program is grabbing a record from a file, doing something, calculating, and maybe there's a value inside that record and that value is zero, and that causes a zero division error. The program will see that as an exception. So everything was running just fine, but you hit a piece of data that didn't work out for you. Now, before I do the demonstration, let's go to my screen and just see some of the built-in exceptions that Python has. And most programming operating systems will have very similar built-in exceptions. Right? So these are Python's built-in exceptions, and I'm not going to go through all of them. This demonstration, we're just going to be talking about zero division, and we kind of scroll around. I know I'm going fast, but here is some exceptions. We got keyboard error, key error, name error. If I wanted to find the divide by zero error, or exception, I should call it, just look up the zero. There's a bunch of them. Here's the exceptions: zero division error. Okay, tells me what to do. It would kick back, et cetera, et cetera. Now, I wrote a series of very small programs because I don't want to get bogged down in the bigger logic of things. So I wrote a series of very small programs, and in each program, I just raised the level of complexity, but it's basically the same program. So let me go, and I have this little program here. And this calculates BMI, body mass index. And for those of you who are curious about BMI, it just basically you take your weight in pounds, divide it by your height squared, and then multiply it by 703. Don't ask me where they get these numbers. I'm just going to use them. So I look at this very, very simple program. We start off by assigning inches to zero, weight to zero, BMI to zero. We ask it for input. We take that input and we convert it to an integer. And then once we have that information, then we run it through the calculation and then we print it. This program does run, right? But you should already begin to formulate some things in your mind. Nick, it looks great, but something may be strange about it. So let's go over here and let's run this program. All right, what is my weight? 265. Height in inches, 75. Runs a calculation. The BMI is 33.11. It's overweight. okay? But don't tell anybody. But could I cause this thing to break? The logic works, the syntax was running. Let's see if I can cause this thing to break. So I'm going to run it again, and this time I'm just going to hit enter here. Now when I hit enter here, input, this input statement over here is going to take that null, that nothing, and try to convert it to an integer. Because you cannot convert nothing or that to an integer, it's going to throw an exception. The program broke. It stopped running. We get an exception error. Here's the exception error. Sorry, that's in black. It says value error, invalid literal for the integer, right? It's expecting an integer, you're giving it something else. Let's run this again. And this time, instead of just hitting the enter key, I'm going to give it junk. I'm going to give it an X. Same thing happens, okay? So this threw an exception based upon me giving it bad input. Let me run this program again, but this time I'm going to give it weight, but I'm going to give it inches as 0. Over here, that should cause an exception because the weight's going to have a value. Then inches will be 0. 0 times 0 is 0, obviously. You cannot divide something by 0. This is going to cause a 0 division exception or a 0 division error. Let's watch what happens. 0, through that exception. And there it is, 0 division error. So we have a whole series of problems here. This program, while it works, is poorly written. So let's look at another program to handle these exceptions. All right. Similar from what you may see in the textbook, we have inches, weight, BMI, but now we're using this exception of try. Basically, try these commands. If they work, great. If they don't work, throw an exception. So let me expand this out just a little bit, make it a little bit easier to read. So it's saying for these particular exceptions, it says try, and I'm only going to worry about the initial input. I'm not going to worry about the dividing by 0 yet. That's going to come later on. And the initial input says, okay, try and see. Let me spread this just a little bit over a little more here. If it throws an exception based upon you giving it bad input, throw an exception and then go on. And that's what's basically it. Here is the try. Try these commands. If they work, great, and you'll see that in other programs. If they don't work, throw this exception where it says print you have a value error expecting an integer got a string. Okay? So let's run this program. All right, weight, I will say 265. And inches, I'll give it X. I'm giving it a string. It should throw the exception, but now it caught that exception. It says you have a value error expecting integer got a string. Go back and fix it. Now again, we have a whole series of programs that are trying to work to improve this. This is a general exception. This is catching, this except here is a general exception. Let's look at the next small program. Now this time we want to get a little more information from that general exception. It's the exact same program that we saw previously, but this time we're going to use the as. And what the as is going to do, it's going to say, if you throw an exception here, if you throw this exception, put that exception value into a string called E, print it. If you go back up here from when I ran 2, I customized the print. I said, you have a value error expecting integer. I want, if I'm throwing an exception, I may want to gather the information so I know what I can really fix. So I could be gathering information that I populate using a customized string or let the interpreter do. So let's run this program. All right. Wait, we're going to say 265. We want to throw the exception, so we're going to say inches X. So now I'm getting here, I'm taking this as exceptions description, throwing it into a string called E, or into a variable called E, and then I'm printing out. So now it says invalid literal for integer with a base 10, you gave me X. Okay, let's go on to the next one. And let's take a look at this one here. All right, so we know we fixed that problem. If we give it a null, we give it a string, we know we're going to throw an exception, we're in good shape. And that is basically what I'm doing here. Let's work on this BMI problem. And let's do it a little clunky. Be really honest about it. I'm going to do another exception down here. Now, and the reason I'm doing it this way, even though it's a very simple program, is we can have exceptions all over our programs. We could be doing a lot of things in our program, and depending on what we're doing, we're reading files, we're doing division, we're typecasting, you name it. Those all have potential of throwing exceptions. So I wanted to kind of separate them just as a demonstration purposes here. So again, we're using the exact same logic. This time, if we give it a string, it's going to throw an exception. We got that. But down here for the BMI, we're concerned about the zero division exception, right? So almost the exact same try. We say try doing this arithmetic, and if it throws an exception, capture that exception, and then print it. So let's go over here, and let's test this. This is 4. Let's break it a couple times. Let's see if we just give it a null, or yep, we threw an exception. You'll notice that here, we also got a division by 0 exception, so it even came down here. That's not good. We may want to clean that up. Let's try giving it a value of 265 and giving it a value of 0. All right, we threw a division by 0 exception. So this first one, again, it just went down sequentially. Because weight and inches were default values of 0, we threw this exception and we threw these 2 exceptions. You can see where this this particular example can get very messy. So let's raise the level of complexity here. Now what I did was I combined the try, right? Because what I know I don't want to capture strings on the input. I know I don't want to divide by 0, so I'm going to shove that all into one try. And I want to be very specific about what exceptions I'm throwing. So the first one is exception value 0. If I throw that exception, then print out, you threw a value, expected integer, got a string. What about the 0 division exception? Yep, doing the exact same thing. So I'm doing this kind of sequentially, and I'll explain why in a second. If I get a 0 division error, throw that exception. And then if I throw something else, anything else, I just pick up that exception. So these are 2 very specific targets, right? I'm concerned about some kind of value error. I'm concerned about 0, but I'm just going to throw. And the reason I did it this way is because if I was just to throw this exception and by itself, it may not give me the information of where it's really happening. The other thing is I got to be very careful about where I put my exceptions. I'm very logical in the exception. If I was to take this exception here and put it up top, it will skip the other 2. It says, I've covered the exceptions, right? I've covered your exceptions. I don't have to go through every single one. Excuse me. So when I hit an exception, it's done. It says, okay, I found one exception for you. Away we go. So let's run this program and let's see what happens. All right, let's see if we can break this. I'm going to give it a string here. Oh, it threw the exception. You'll notice that it just threw the one exception. It picked up that exception, handled it, and it went about its merry way. You notice it didn't worry about the BMI after that, right? Because what happened was the very first thing it did was it tried to convert a string to an integer, didn't like that, so it threw the exception. Here, kicks it out. Okay, let's run this program again. This time I will do it again. I will say 265, and I'll give it, still throwing the exception, all right? So we know those two lines are working. The exception for the value error exception is working. So it doesn't even go down to the BMI yet. So let's run this program again. This time let's give it a value of 0. 265, 0. Those are valid integers. 265 is a valid integer. Height of 0 is valid. I know I'm being silly here. This should be fine with the value error exception, but the BMI should have a problem with this. Oh, and sure enough, division by 0, expecting a height greater than 0. Okay. So I can't think of another exception I can throw here, so I'm not going to worry about this last thing here. Let's elevate this now. We want to print out the BMI. If I give this a valid information, this program really doesn't do much. 265, 75, that's it. Program ran, figured out, but it didn't print anything back to me, okay? So now I want a program that is going to print something back to me if it's all valid. If it's all valid, print out the BMI. So let's go to the next one. And let's take a look at this next one. Okay, there's our try, there's our exception. Now we're using this else, very similar to an if-else. Now, this else will only be executed if the try does not throw an exception. If this try does not throw an exception, print out the BMI. If it throws an exception, you can't do anything, right? The program is not working. But if everything works, we should see a BMI. All right, 265, 75, no exceptions were thrown, therefore it hit this else. The else is in the try statement. The else only gets executed if everything in the try worked just fine. Because everything in the try worked just fine, we're in good shape. Now, there is one more part of this, these exception handling that I'd want to point out. It doesn't make much sense for this, but just try to explain it. We have the try, we have the accept, and we have the else. We've covered that. We then have what's called finally. We don't have to use finally, but finally is used that no matter what happened, whether we threw an exception or not throw an exception, you still need to do that. This is often used if you're looking to control file management. Let's say, for example, you open up a file, you do a whole bunch of stuff, and then you need to close the file. You need to handle that file appropriately. Well, this, by using the finally, it says no matter what the outcome is, still do these tasks. So let's say you open up a file, you do a whole bunch of things, maybe you threw an exception, you still got to close that file, right? You open up a file, you do a bunch of things work perfectly, you got to close that file. So Finally is only used when you have to make sure after all this madness, after all these either exception or no exception, you're still going to cover it. So this program is nearly identical to the previous one, with the exception that we should always see finally, regardless of success or exception. So let me clear this. All right, I'm going to throw some exceptions here. First one, I'm just going to give the height a bad value. It threw the exception. It says, okay, let me stretch this out just a little bit here. Invalid, I was expecting an integer. Executing finally, regardless of success or failure. This was really a failure. This was an exception, so it's going to do the finally. Let's run this program again. And this time we're going to do a BMI problem. We'll say 265, 0. It's working. Division by 0, expecting a height greater than 0. Executing finally, regardless of success or exception. And then finally, let's give it valid data. 265, 75, good. The BMI was 33.119, blah, 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 blah. Executing finally regardless of success or failure. So let's recap this. Let's recap this. We have syntax errors. Those are typos, those are grammars, you're not putting in the stuff the way it's meant to be put into. Those are easily discovered by the interpreter or when you try to compile the program. You have logic errors. Those are tough. It looks like it's running, but you're not getting the results that you're expecting. Then we get into these runtime errors or exceptions. I call them exceptions, but they are runtime errors, which means syntax is fine, logic appears to be fine, something's going on with the data that's causing the program to have issues. So you have to do some kind of exception. Now, if we look at these programs, these very, very simple programs, could I manage these exceptions within the program without using the try and exceptions? Absolutely. I could put logic in there that would basically say, okay, if you're divided by 0, I'm never going to allow you to do that. You'll just keep asking for the information over and over and over. Could I write logic that if I'm reading a file and I get data that is not good, don't deal with it? Absolutely. So you don't have to use exceptions. They are used quite frequently in programming, but there's other methods to capture those exceptions or do things to those exceptions. Most of the time, if you're grabbing something from a file and you hit an exception, you just grab the next piece of information, maybe record it or things like that. So cover a lot of material. I know it can be overwhelming, especially when we're dealing with the tries and stuff like that, but they're just methods to make sure that your programs are running just fine. So that being said, let's go on and learn something.